All right, here we go. Chapter 2 review. Getting ready for the test tomorrow. This was a really short chapter. There was only 4 or 5 sections, so it went kind of quick. I think the best way for you to prepare for the test, though, is do the review on your own, then go on Schoology, check the answers, and the ones that you got a different answer, or maybe you got the right answer but you guessed, then you want to come back and watch this video for the problems that you need some help on. So I will start kind of breaking it down and going through it right now. So first section, true or false. Number 1, is it possible for adjacent angles to be supplementary? Well, remember, supplementary means they add up to 180. Adjacent means that they share a side. So could two angles share a side and add up to 180? Sure. An example would be angle 1 and angle 2. Those guys add up to 180. They are adjacent because they share this common side. So I believe this one would be true. Number 2, is it possible for adjacent angles to be vertical angles? Well, remember, vertical angles are whenever you have two straight lines. Vertical angles are the angles that are kitty corner from each other or across from each other. So if those two angles are both vertical angles, the only thing they share is a point. They touch right here in the center. So this one is false. Vertical angles cannot share a side. Number 3, is it possible for vertical angles to be supplementary? It is possible. The only way that can happen is if the two lines are exactly at 90 degrees to each other, because then you'd have 90, 90, 90, and 90, and then we would have a pair of vertical angles, or angles that are across from each other, that do add up to 180 degrees. So yes, this is possible. Rare, but possible. Number 4, a good definition can always be written as a biconditional. That is true. Remember, a biconditional means that P then Q is true, and that it also means the converse, Q then P, is true. All definitions should be able to be written in that format. And the key part about that is the words if and only if are used in the definition. Number 5, deductive reasoning uses patterns, observations, good guesses. That is false. That would be inductive reasoning. And you should have learned that from your vocab quiz. Number 6, the converse of a true conditional is always true. Well, that is false. And we had several examples in class, but I could say something like, if you live in Ann Arbor, then you must live in Michigan. Assuming there's only one Ann Arbor out there, then that would be true. If you live in Ann Arbor, then that makes you living in Michigan. But if you go backwards and you do the converse, if you live in Michigan, then you live in Ann Arbor, that would be false. So the converse is not always true. Number 7, if 2 points lie in a plane, then the line containing them lies in the plane. This was one of our postulates. So I have a plane, and if 2 points lie in the plane, lie on that flat surface, then any line that goes through those 2 points, yes, that line must also lie in the plane. So that is true. Now, the opposite of that would be if I had a plane and I had a line intersect it, or come down, hits through, comes out the bottom. That would be a line that intersects the plane, but it only happens at one point. You can't intersect it at 2 points and not be laying flat in there. Number 8, proofs illustrate deductive reasoning. That is true. Deductive reasoning is powerful reasoning based on facts, logic, postulates, properties, theorems. Number 9, there's a symmetric property for equality and for congruence. That is true. Symmetric property basically says if, say, x equals 2, then 2 has to equal x. It just says you can flip what's on each side of the equal sign, and it's the exact same equation. Complements of congruent angles must be congruent. Complements of congruent angles have to be congruent. Well, complement means you add up to 90. Okay, you add to equal 90. And so if I'm looking at the complements of two congruent angles, so let's say that an angle is 23 degrees. Well, another angle that's congruent to him would be the same measure. So their complements, their complement would be the other angle that it makes them add up to 90. So 67 would be the complement to 23. But if these two angles are congruent, then their complements must also be congruent. So that is true. It's a little bit tricky one, but it is true. All right, moving out of true and false, moving into some multiple choice questions that are kind of going to simulate what's on the test. Number 11, given the statement, if an angle is obtuse, then its measure is not 40. So this is my hypothesis, or my P, and this is my Q. Its measure is not 40. Compared to that statement, identify which type is as follows. If the measurement of an angle is 40, well, when I look up at the above equation, this portion was the Q before, but not only was it Q, they got rid of the word not. So they negated Q, and they said it's not obtuse, so then it negated P. So not only did they flip P and Q around, but they negated both of them. And that is an example of the contrapositive. You take the original statement, you flip the if and the then, and you negate both sections. Number 12. So again, I'm looking at this. The P part is a triangle of isosceles. The then is it has two congruent sides. Let's see how they switch this one up. So they said if a triangle has two congruent sides, so they basically just took this original Q and put it in the front, and then they took P and they put it in the back. So it's kind of like the example before, except for they only switched P and Q. They didn't negate both of them. So when you just switch P and Q, that would be what's called the converse. Okay, the converse is when you just reverse the order. All right, number 13. Given the statement, if a polygon is a hexagon, then it has 6 sides. What is the hypothesis? Well, the hypothesis is whatever comes after the word if. So a polygon is a hexagon. That is the hypothesis. So that looks like it would be part A. All right, moving on down to the next page. So number 14, another term for the law of syllogism. And I don't know if we actually described it this way in class, so this wouldn't be really a fair test question. But another name for the law of syllogism is some people call it the chain rule. I also think it's very similar to the transitive property. And basically the law of syllogism says if 1 leads you to 2 and 2 leads you to 3, therefore, that's what this little symbol here, therefore I can conclude that 1 will lead you to 3. You basically just can skip right from the beginning to the end and take 2 right out of there. Number 15, consider the pattern of numbers using inductive reasoning. So look at the pattern, try to predict the next number. Well, for number 15, it looks like, and I can look at this several different ways, but it looks like to get from -3 to -1, I think we added 2. And then it looks like we added 4. From 3 to 9, we added 6. So there's this addition pattern where it's getting bigger by 2. So I think we would need to add 9 plus 8, and we would get 17. So that one, the correct answer would be D. All right, I'm going to scroll on down a little bit so we can get the full diagram in for number 16, 17, and 18. So we have this diagram to the right. We have some information here. I'm going to label the picture. It says, first off, GC that's a symbol for perpendicular, or 90 degrees. GC is perpendicular to BE, so which means this right here is 90 degrees. HT is perpendicular to HF, so that means this is 90 degrees. HA, ray HA bisects, okay, bisects means chop in half, so ray HA chops in half angle G to H to B, so that means this angle here equals that angle there. And then they give me one measure. They tell me the measure of angle 4 is 60. So angle 4 is 60 degrees. And now they want me to go through and answer some questions. So let's look at 16. Who forms a vertical angle with CHE? Well, angle CHE would be C to H to E would be this angle right here. So what you do is you continue the straight line, continue this line across, and then continue the other line across, and it would be the angle that's kitty corner with it. So it would be this guy, which would be GHB or BHG, and so I think that would be part C. So this one is C. Number 17, what is the measure of angle 2? Well, I got to kind of use some different strategies here, and I'm going to kind of go back and erase a little bit of this. We did know that this was 90 degrees, which also means that these two add up to 90, which also means that these two add up to 90, which is also going to mean that these two add up to 90. Okay, so you have 4 sets of 90, and we do know that this one is 60 degrees. So I should be able to figure out this one. This one right here is 30 degrees because 60 plus 30 is 90. Let's see how that's going to help. Well, another thing I can do right now is, since these two angles right here are 90 degrees, and I learned earlier that they were congruent to each other, that means they're both 45. So I'm starting to kind of work my way around here. So it looks like here I have to use this clue that HD is perpendicular to HF. So HD perpendicular to HF means that these two right here are also 90 degrees. And so since this piece is 30, that piece is going to be 60. All right. And then since these guys had to be 90 degrees, it looks like that is 30. So that picture got a little bit complicated here. So that would make this one would be A, 60 degrees. And the measure of AHC, so A to H to C would be this entire section right there, which would be 90 plus 45. So that would be 135. That would be D. That one was a little bit tough, especially number 17 there. All right, moving right along down to number 19. Which one of the following is not one of the point liner plane postulates? Which one is not? I believe this was in section 2.3. A plane contains at least 3 non-collinear points. That is in there. If 2 lines intersect, their intersection is exactly 1 point. That's yes. A line contains at least 2 points. That is correct. Coplanar points are points that lie on the same line. This is not correct. Coplanar points are points that lie on the same plane. So that's the error in that one. Or they could have said collinear, not coplanar. But that's part D. Number 20, which one of the following statements can be determined from the figure? So we're looking at markings and we can't assume anything here, except for if a line looks straight, then it probably is. It's about the only thing we can assume. So let's double check through this one. Part A, is angle ABL congruent to JBK? So ABL, angle ABL, that would be this angle. Is that congruent to JBK? JBK, all right. That cannot be determined. So this is no. So we can't assume that. Let's check point number C here. Are A, B, and J on the same line? A, B, whoa, J's way up there. A, B, and J are not living on the same line. They're not collinear. Part E, is MB congruent to BJ? MB and BJ. Well, MB is this section right here. BJ is this section right here. I have no markings that say that, so I'm not allowed to assume, even though if they look alike, still won't work. Part B, does JM bisect LK? So let's try this one here. JM bisect LK. Well, here's JM. Does JM chop in half LK? And it does. these two markings right here show that from L to K got chopped in half. JM did it, so this one is true. And the perpendicular part is CK 90 degrees to AC. You know, it looks like it, but there's no markings in there that I need something like this, so this one will be out too. So the correct answer is B. All right, moving on to the back page. What property of equality is illustrated by the following? If A equals B, or if AB equals BC, then BC equals AB. It looks to me like all they did was reverse the two sides of the equal sign. So that would be the symmetric property, when you just reverse the two sides. What property of equality is illustrated in the following? If A equals B, and then B equals C, how do we know that then A equals C? That's kind of what this says. That is the transitive property. Also very similar to the law of syllogism. I would never put both of these as answer choices because they're very similar, but that is the transitive property of equality. Use the diagram for these last couple problems, so let's scroll down, see how we can do on these. And I pretty much have to find the relationship between the angles. So a couple relationships I see right now. This angle and this angle are vertical angles. They are equal to each other. So I can start off and set up an algebra equation. The angle on the left, 3x plus 18, has to equal the angle on the right. And then I start using some algebra. I'm going to subtract 2x from both sides, or not 2x, I'm going to subtract 3x from both sides, which is going to give me 18 equals 2x minus 4. I'm now going to add 4 to both sides, which is just going to give me 2x equals 22. And my last step, I'm going to divide both sides by 2, and I'm going to get x equals 11. So the value of x must be 11. Now, how can I find the value of y? Well, here's what I'm going to do. Since I now know that x is 11, I'm going to plug it in, and I'm going to find the true measure of the angle. So that will be 3 times 11 plus 18. So that's 33 plus 18. That's 51 degrees. Now, the relationship between this angle and that angle, they're not equal to each other, but they do add up to 180 degrees. So if this portion of the angle is 51, I can find this side basically by doing 180 subtract 51, and that would be 129. So I know that this arc right here is 129 degrees, but now I need to solve for it. So when is 3 times y plus 33 going to equal 129? I basically set these two equal to each other. And I use the distributive property, 3y plus 99 equals 129. I subtract 99 from both sides, 3y equals 30. And then I divide both sides by 3, and I get y equals 10. So the correct answer for this one is C. Number 25, I believe this is the last one on our sheet. If point B is the midpoint of AC, so let's just draw this. I have a segment AC, and point B is in the middle. Point B is the midpoint, so I'm going to put markings there to show it's in the middle. Then point B bisects AC. If point B bisects AC, then it's true that segment AB is congruent to, or the same length as segment BC. What logical conclusion can be drawn using syllogism? All right, so let's think about syllogism. It's kind of like that transitive property. And the flow is, you know, if 1 equals 2 and 2 equals 3, your conclusion is that 1 equals 3. So let's kind of try to take this up above. So here's my first if. If point B is a midpoint, we're going to call that number 1. Then point B bisects, so that's part 2. So 1 leads to 2. That would be this arrow over here. 1 leads to 2. And then you'll notice this 2 gets repeated. So that way 2 then goes to 3. 2 goes to 3. So your conclusion using syllogism is that 1 goes to 3. So that should be the conclusion. If point B is the midpoint of AC, then this statement, so I think that matches up with part A. That's the one that goes from 1 to 3. That's how I structure those in my mind with the transitive property or syllogism. I like to kind of ignore all the little pieces and just kind of look at the chunks. Look at these big chunks here that represent the P's and Q's and R's, things like that. Hopefully this helped. If not, you're going to get the opportunity to ask me some questions in class tomorrow, right before the test. Probably limit that to 10 minutes or so. Hopefully the majority of your questions got answered using this video. So good luck tomorrow on the test, and let's get after it. Show me what you know. See ya.